We're looking at the back of PracA 1.2. We're going to do numbers 28 and 29. Number 28 is about a cell phone. It says to measure the length of the cell phone without the antenna to the nearest 1/8 inch. Then measure the length of the antenna to the nearest 1/8 inch. So you're going to need a ruler. Okay, so hopefully you have a ruler. Again, make sure you're using the correct side. We have a metric side, and then we have our inches side. Okay, so from the 0 to the 1, there's 16 spaces. That's what that tells you here. It's each little space is a 1/16 of an inch. 1/8 of an inch would be 2 of those, because 2 little spaces would be 2/16, which reduces to 1/8. So you're looking for this distance right here. That's what we're measuring to, nearest 1/8 of an inch. Okay, so we'll measure the cell phone first. It's definitely bigger than 3, and actually makes it to about 3.5, it looks like. Okay, and 1/2 is in a denomination of 1/8 of an inch. So if you're counting by eighths, you would go 1/8, then another eighth would be 1/4, and then another eighth onto that would be 3/8, then another eighth on top of that would be 4/8, which is 1/2. Okay, so 3 1/2 is rounded to the nearest eighth of an inch. Now we're going to do the same thing for the antenna. Just measure the antenna. Okay, and it looks like it's 3/4 of an inch because we're directly in between the 1/2 and the 1. That's 3/4. So if we were counting by 1/8 of an inch, we would go 1/8, 2/8, 3/8, 4/8, 5/8, and 6/8. That's how long that antenna is, 6/8. But when you reduce it, you end up with 3/4. So measuring on a ruler is as simple as counting and then reducing. Number 29, that's about a highway. You are traveling on a highway starting at point A. After you have traveled 63 miles to point B, you see a sign that says that it is 87 miles to your destination, which is point C. So notice how this diagram kind of models that. Here's point A, here's point B, 63 miles away. Here's point C, 87 miles away. Now, one thing you can recognize here is that these 3 points are collinear. So you should automatically be thinking of a postulate that we talked about in class, segment addition postulate. Little plus little equals big. Find the total distance you will travel to get to your destination. So we're going from A to C. Little plus little equals big. So we'll write it out down here just so you kind of get the feel for the segment addition postulate. A to B plus B to C equals A to C. Now this is a simple problem. You could just add these up if you wanted to, but we're going to plug in and you'll see why in the future. So we're just kind of modeling the way to do it this way with a simple problem. A to B is 63. B to C is 87. That's how far it is from A to C. Just add those together. Okay, so that's the total distance that you're going to travel to get to your destination. Now, sometimes they give you units, sometimes they don't. It looks like they do here. So we're talking about in miles. Okay, so from A to C is 150 miles. Part B, you are traveling at a constant speed of 60 miles per hour. How many hours will the entire trip take? Okay, well, we know we have to travel 150 miles. If you're traveling 60 miles per hour, think about what that means. If you've been traveling for 1 hour, how far did you go? Okay, you went 60 miles. That's what that means. So after 2 hours, you went 120 miles. If you travel for 3 hours at 60 miles an hour, you're going to travel at 180 miles. Okay, so you're only going 150 miles. So it's definitely going to take you more than 2 hours. It's not going to take you 3. How did I know it was 2.5? Well, 150 is directly in between 120 and 180. Okay? So another way you could do this is you could take your distance, 150, and you could divide it by your miles per hour, 60. 150 miles traveled, you're doing 60 miles every hour. How many hours is that going to take you? 2.5.